Okay, good morning, everybody, and a very warm welcome to this working webinar. It sounded better than a Teams meeting. So, very warm welcome. We are going to get cracking. And to do that, I am going to start my presentation. Right, just by a thumbs up or a show of hands, can someone confirm that they can see the screen, please, to make sure digital is working? All good, great stuff. Thank you very much. So really, thank you so much for agreeing and accepting this invitation. We did, in fact, have 60 people register, but there's always a significant drop-off. And because this is not a typical webinar where everybody is muted, the rules of the game are please to just try and remember to keep your microphone muted and remember to turn it on. After 3 years, I still forget to do that. And what we're going to do is I'll do a quick introduction to the South African Circular Minerals and Metals Initiative. Then Samaya Khan is going to present the findings of research that was done in 2022. And then we are getting into the real meat of the day, where very kindly people from across the world have agreed to give us 10 minutes of their time sharing the circularity circularity activities and initiatives that are actually in play right now, because that's what today is about, is what's actually happening. We will then we'll probably have a quick break after that because it's a long time in our seats. We will then do a plenary digital survey all together, and then there will be breakaway rooms where people will be doing the work in separate rooms. And then we will have a report back. So let me get cracking into what is the South African Circular Minerals and Metals Initiative. And it stems very, very superficially. Obviously, I've only got about 5 minutes left. Metals and minerals are obviously a finite non-renewable resource and typically have been left out of all the discussions around circularity because mining is seen as a purely linear and extractive process, which obviously it is, but there are massive opportunities to introduce circularity and to even change business models for mining. In South Africa, we all know how important mining is to us and what it has done to build the country, to build the economy. But the reality is, as you will hear from Samaya, is that there is resource security is not necessarily a given. If you adopt a longer term time frame, which obviously in terms of the sustainability aspects, we try to adopt that long-term time frame when making decisions today. And in this initiative, and I'm very pleased to have Prof. Linda Godfrey with us, who runs Circular Innovation South Africa. In the circular economy, we're trying to match human economy to be in harmony with the realities of the rules of nature. And so this is what we're trying to do for metals and minerals. And there's a lot of benefits in this. Obviously, minerals and metals drive a lot of the projects and developments and innovation around how to create a more just environmental and social transition, as well as a new digital economy. And this presents both risks and opportunities for South Africa. The SACMMI itself is the first of 3 sub-initiatives under CISA, and we are trying to elevate that's the wrong word. We're trying to bring the national system of innovation much closer to industry, be it mining or agriculture or manufacturing, so that we work in concert with each other to produce better results in research, development, and innovation for the future. And it fits, this image is from CISA, it fits perfectly into the national government priorities and the medium-term development plan. I also wanted to take an opportunity just to introduce the precinct, because many, many people don't know who we are. We arose out of the mining pakisa the mining pakisa itself was 2015, MMP was created in 2016. And we believe, we don't have the stats, but we believe we are the largest research, development and innovation public-private partnership. We are funded on a 2-to-1 basis by the Department of Science, Technology and Innovation and the Minerals Council South Africa. But the uniqueness not only of our structure, but how we operate is that we don't do the research ourselves. We have a network of collaborators and we run expressions of interest for that every year. And so our job is to channel the research programs and the accompanying funding through into this collaborative network to get the National System of Innovation working on real problems to help solve, in this case, mining issues. And that collaboration and partnership is also the way that we will be running the SACMMI work, although we are working under the Circular Innovation South Africa. And this was launched in April this year. And this is the initial, and please, very initial ideas about the science, technology, and innovation focus areas and the potential model for SACMMI. Typically, circularity in mining is only looked at the use, the waste space. And we believe there's massive opportunities both in the availability, the extraction, and the use. And so in availability, it's about understanding what resources are where, ideally in real time, and how we can use them, and where they are best used, and what the resource security situation is around each of the commodities and minerals. At the extraction, circularity at the face, it's very much the operational water, energy, waste kind of where can we introduce circularity practices there. And then obviously in the use, it is about processing substitutability, the net zero value chains. And I'm delighted that we actually have a number of examples of this in our presenters today. And I think that is all I am going to actually say. Yes, so I am going to stop sharing my screen and I'm going to ask, I think you're up first, Will Wardle from the ICMM, to go ahead with his presentation. And I'm going to be a brutal chairperson and try and keep to the 10 minutes. But please, if anyone has questions, please pop them in the chat. This meeting is being recorded, it's being transcribed, and we'll do our best to... Oh, sorry, Samaya, it's you. Beg your pardon. Well, sorry. Step back. Thank you, Samaya. This is live TV. Samaya, you have 15 minutes. Thanks very much.
Thank you. Thanks, Julie. And good morning, everyone. Julie, thank you for this opportunity. Let me share. All right, I'll get straight into it. So between 2021 and 2023, the CSIR undertook a multi-sectoral circular economy study, which was led by Professor Linda Godfrey. The project involved various thematic areas within the CSIR, and mining was one of those areas. And the objective of the mining sector study was to determine if resource scarcity is a driver for South Africa to transition to a circular economy. We also explored some of the circular economy opportunities and interventions for the mining sector. So the reports for the various thematic areas can be found on this website. I will also post it on the chat later on. So we aim to answer these 4 research questions, the first one being how many years of economically viable minerals and metals does South Africa have? And then we wanted to understand what South Africa's critical raw materials are, or critical minerals. And then based on the first 2 questions, is resource scarcity a driver to transition to a circular economy? The fourth one is on circular economy opportunities for the mining sector. And this will be the focus of this presentation. However, I will briefly touch on the first 3 as well, just to give you an indication of our findings. Okay, so to determine the number of years of economically viable mining remaining in South Africa, we used reserves and annual production data in our calculation. And we found that some minerals such as gold, cobalt, iron ore, and a few others shown here have less than 50 years to depletion. And this, of course, raises concerns about resource security. Then to understand what South Africa's critical raw materials could look like, we found that there was no well-defined methodology to determine our critical raw materials. So we linked CRMs to emerging technologies. However, the DMRE, together with the Mintech and Mistra, are in the process of developing South Africa's critical mineral strategy, and this also includes South Africa's critical minerals list. The table at the bottom here is a snapshot of the emerging technologies that will drive the demand for mineral resources in South Africa. For example, hydrogen fuel cells will require platinum group metals, rare earth elements, cobalt, and a few others, whereas solar PV cells will increase the demand for rare earth elements as well as copper and aluminium. So this is a summary of all the critical minerals identified. It's shown on the periodic table and on the list on the left-hand side. And the ones in bold indicate the minerals that have less than 50 years to depletion. The ones shaded out, aggregate and limestone, were highlighted as important for our construction industry based on the stakeholder engagements that we had. What we realized is that critical minerals can be categorized according to various applications, for example, for energy transition, for local economic development, for national security, etc. So our focus at the time that we undertook the study was on energy transition minerals. So just to sum up those first three research questions, from the first one, we found that certain minerals have less than 50 years remaining. And then based on the second question, these minerals may be classified as strategic in South Africa. And this suggests that resource scarcity may in fact be a driver for South Africa to transition to a circular economy. So moving on to the opportunities, these are categorized according to the three principles, the first being designing out waste. We did not do an in-depth case study on any particular intervention or principle, but rather we want to get a general feel for what is possible in line with each of the principles. So without going into detail with each of them, I'll just touch on a few. The first one being increased ore extraction and precision. This could be impactful because it tackles waste at its source. So some examples are coarse particle recovery and bulk ore sorting, both of which reduce water and energy consumption. In situ mining through leaching or solution mining is another example where the ore is targeted and waste reduced at the source. The second one, water recovery and recycling. This is crucial to address water scarcity issues in the country. And this could be done through dry mineral processing, evaporation management, as well as dry stacking of tailings. And the last one I will cover here is biotechnology or biomimicry, which is used to recover metals from appliances, cell phones, etc. And I think this work is currently being done by Mintech. The second principle presents the low-hanging fruit for the mining sector. A lot of these initiatives are currently happening at mines, so most of these opportunities are not new. One of the most common being reuse and repurposing of waste, example, backfilling of waste rock, use of aggregates for construction, tire recycling, etc., as well as using tailings waste for construction material. The second one, metal recycling of electronic scrap. This can go hand in hand with the urban mining of e-waste. Processing of secondary metals also involves melting of scrap in combination with primary concentrates to produce valuable metals. Remining of tailings, this gives the mining industry an opportunity to convert legacy mines into alternative economies through the waste, which can then in turn create employment opportunities. And in terms of regenerating natural systems, when it comes to integration of renewable energy, Goldfields South Deep Mine constructed a 50 megawatt solar plant to partially mitigate the impacts of load shedding. And the benefits of this was about a 24% cost saving in electricity for the company, as well as a reduction in carbon emissions. In the green hydrogen economy, this has huge potential for South Africa. For example, it could increase the demand for platinum group metals. And as we know, South Africa hosts the world's largest reserves of PGMs. And the third one here is repurposing of post-mining landscapes, for example, into educational training centers or for agricultural or tourist attraction purposes. Okay, I will now just briefly touch on some of the circular interventions or research and development projects that the CSIR as well as partners are involved in. Okay, in terms of general waste, mining companies in collaboration with municipalities could develop materials recovery facilities or sorting facilities. And the benefits of these is that it can reduce environmental impacts caused by dumping. It could minimize the volume of waste reaching landfills, and it could also stimulate local job creation by involving the mine communities in these initiatives. And through the Coaltech Research Association, we are investigating the repurposing of coal waste for use in asphalt mixes for the construction industry. The literature indicated that this has worked in some countries globally. However, there is a gap in knowledge in the South African context. The Impact Catalyst recently embarked on an initiative to remove alien invasives from around mines in Limpopo. The removal of these plants resulted not only in water being released around the mines and communities, but they were also converted to energy pellets, which was found to be a safer and more cost-effective alternative to paraffin. So this obviously addressed a lot of environmental degradation issues as well as socioeconomic needs of the communities. Our water center is investigating sustainable acid mine drainage approaches for the mining sector, which could potentially support some of the sustainable development goals. They are not only investigating water reuse, but also the recovery of valuable minerals from the acid mine drainage. And last but not least, our biorefinery facility is undertaking research to valorize wood waste into high-value products such as xylose and pine oil. So traditionally, wood chips would be used to produce compost, which is a low-value product. However, this shows that through research, development, and innovation, high-value products could potentially be unlocked from waste. So just to conclude the presentation, some of the key messages from our study is that a circular economy can provide opportunities for the mining sector, including those aligned with the 3 principles, as well as opportunities for new business models. And secondly, the most implementable circular economy opportunities in the mining sector are those aligned with the keeping materials in use principle. That's the 2nd principle. And many mining companies are already implementing practices aligned with this principle. And these include practices such as reducing, reusing, recycling, repurposing, etc. And there is a need for RDI to unlock value from waste, as we saw from some of the previous examples. Then the high impact opportunities aligned with the 1st and the 3rd principle of designing out waste and regenerating natural systems are more difficult to implement as they require larger financial investments. And then finally, even though some mining companies adopt circular economy principles, the interventions need to be scaled up to make a meaningful impact on businesses, society, environment, and the economy as a whole. Thank you.
Thank you so much. You are, I think, 2 minutes early, actually 3 minutes early. So thank you.
I saved you about 3 minutes.
Yes, I know. I even told you had 2 minutes when you actually had another 7. So thank you very, very much. And again, if people want to put questions in the chat, please do feel free. So now, as I said before, we're going to pass over to Will Wardle from the International Council on Mining and Metals, who's very kindly agreed to share what they are doing. Thanks, Will. Go ahead.
Thank you, Julie. And yeah, great to see you all this morning. And thank you very much for the invitation to speak here. So I think before I dive into this, it's always really useful to just give a bit of an overview of who the ICMM are. I'm sure many of you may know this by now, but we are the International Council of Mining and Metals, and we represent a third of the mining industry, with members across the globe. So common ones in South Africa, you may well be aware of Anglo-American Goldfields or Sibanye-Stillwater. And really the aim of our organization, as like I say, you will already most likely be aware of, is how can we contribute or increase the contribution of metals and minerals to the Sustainable Development Goals, and doing this in a collective and collaborative manner. So that's my spiel out of the way, but just to give those a bit of background if you weren't aware. The Circular Economy project, and this is a project that I work on primarily at the ICMM, is really an interesting one. And you talk about mining and circularity, and quite often people struggle to see the connection there immediately. So I think just before I dive into how we approach the circular economy, I think it's really important to situate ourselves in context. So there are two factors in the context that I feel are really important to draw attention to. The graph on the left of the screen here, indicating the increased need for metal. We need a lot more metal if we are going to meet the demands of the green energy transition, with some predictions saying the need for lithium by 2050 will be 15%, whereas nickel will be somewhere between the margins of 10 and 15. And it's also suggested that, I think by benchmarking intelligence, we need 300 more mines. This is a lot of mines, and I'm sure you are all aware of how difficult it is to open and permit new mines. And I think what's really clear is then people say, oh, let's just recycle more. An issue we have with that, even with optimized recycling, we will fail to meet the demands for the green energy transition, with the Energy Transition Commission saying we will only meet 45% of the demand for copper, even with optimized recycling. So that's context number one. We need more metal. Context number two on the right of this screen is Rockstrom's planetary boundaries. These really indicate, or it's a theory, that we have surpassed 6 of our 9 operating boundaries. Again, indicating that we are in a planetary crisis. So we need more metal on one hand, and then on the other hand, we face sustainability demands and issues, which means if we are to produce this metal, it must be done so in a more sustainable or as sustainable a manner as possible. So this leads to our approach. The ICMM, we've worked for 3 years or so to really understand an approach to circularity that is more nuanced and, as Julie said, takes into account primary extraction and the importance that it roles in enabling broader circularity. So this diagram, our infinity loop, represents how both process, so at mine site operations, it requires circularity and can be a growth area for circularity, but then also how product circularity is just as key. So process circularity is the idea, and similar to the work you were talking about, Julie, is at the face. If we are mining, how can we apply circular principles, be that in the elimination of waste, the reuse of waste, the reduction of emissions, the regeneration of land sites post-closure? So really, what are we doing at mine sites to improve circularity? And then the second part, to the right of this diagram, is product circularity. Once we have created metals, which are known as inherently durable, how can we make sure that the mining industry, along with the broader value chain, can maximize the value in these metals to enable greater circularity? So this is really how we understand it. And I think we work incredibly hard to make sure that the circular economy is actually comprised of not one circle, one loop that reduces primary mining, but actually one that can maximize the value within the operations of primary mining and then the materials they produce. And so a bit of work we've done over the last 3 years, we really kick-started it with a research project with the Columbia Center for Sustainable Investment. I will share these slides later with the links, so please don't worry about reading all of this. But this paper was really an attempt to understand within renewable energy value chains, what are the tangible steps we can take to improve circularity. If we are having all this renewable energy, wind farms, solar panels and whatnot, how can we ensure that mining and metals can be extracted in the most circular way possible to enable this shift to the green energy transition? So this was really our first piece. And from that, we provide, or the Columbia Center for Sustainable Investment provided recommendations to policymakers, metals and mining companies, renewable energy manufacturers, and broader value chain actors. From there, we have recently launched the ICMM Tools for Circularity. In fact, earlier this month. So it's fantastic to be on a call and being able to speak about them. These tools are short, accessible, and practical tools that we hope that the membership, ICMM, and also the wider industry can use to improve circularity. Like I say, both at process level and product level. And I think throughout all of this, we really wanted to highlight the value of circularity, not as a tool for compliance, but actually an opportunity, as Samaya was saying, for multiple opportunities, be that environmental, social, and also economic. We're very aware that the circular economy is an economic opportunity. And when working with businesses, it's incredibly important to make that clear. This is a potential area for growth. And again, these tools always harking back to the idea of metal being inherently suited for the circular economy. These tools were developed with the mining industry, with our 24 members and external value chain stakeholders. So we really hope they offer practical tools. And I would suggest, if you have any questions about this presentation, please go and visit them, as they contain a lot more information that I will be able to cover today. So the 3 tools themselves, we have how mining and metals fit into the circular economy. This really aims to provide a unified language to understand mining and metals' role in the circular economy and overcome this oxymoron of the idea of circularity and mining, or primary mining. We also look at the value and the benefits, and then also what work is already being done by ICMM and the mining industry that could be considered to apply with circular principles. Whether this be good closure practices, whether this be the regeneration of land sites, whether this be the decarbonisation of our operations, lots of work is already being done, and we really wanted to bring attention to that. The second point is building a business case for circularity. Like I said before, businesses run through economic ideas. We're well aware of that. And so how can we translate the ideas of a circular economy to the kind of economic argument? Why it matters, what are the key drivers, and what are the key momentums? And then also kind of diving into the potential ways to measure. So that's that tool. And then the last tool that, as Julie said, we're kind of looking for tangible examples, I feel is most important to this group, is the circular economy case studies in the mining and metals industry. This is a catalogue of examples across our membership and across different commodities and different geographies of circular economy principles that are being applied at mine site. So in the last few minutes, I thought I would just quickly dive into 3. And I've chosen to do this in focusing on process and product, and then product. So really the idea of moving and highlighting that circularity can be achieved in multiple ways, or contributions to circularity can be achieved in multiple ways. And there is no one size fits all. So this process circularity example for Rio Tinto, for instance, in Quebec, where they mixed hydrogenated lime with calcium into the calcinator to produce calcium sulfate. This was then used in local communities and in agriculture to manage soil acidity. So this led to 17,000 tons have been used by local businesses and local communities in a positive way that would once have been considered waste. again, highlighting the opportunity for both the mining company to reduce waste, but then also local business opportunities. The second point, which is a bit of both process and product, is Vale's work in Brazil to minimize their tailings and also understand how they can repurpose tailings, which is often a liability. So with this, they repurpose and reprocess iron ore tailings to create iron pellets for use in business, avoiding 540,000 tons of CO2. They also then take the substance of the tailings themselves to create blocks, pico concrete blocks. And I think the latest figure was they've created 30,000 of these for building. And then lastly, as I realize I'm coming up to 10 minutes, is Glencore's work on recycling e-waste. They've been doing this for over 75 years, and they are doing this with an economic incentive. This is a way to make money. So they recycle end-of-life electronics, lithium-ion batteries, and other critical metal-containing products. And in 2022, they recycled 31,000 tons of copper. And so just before I wrap up, I think what I'm trying to indicate here with these examples is there are multiple ways to do circularity within the metals and mining industry. However, all of these contribute to improved contributions to the Sustainable Development Goals, be that in working towards a net zero future, a nature positive future, and also a just transition. And so the circular economy is a way to encompass many of these multiple points, but it is being done today. And we really hope that with the publication of our tools, we can continue to support the development of the circular economy in no matter how it looks in the mining and metals industry. I think that's all from me, Julie, and I hope I kept to time. And again, a big thank you for enabling us to speak here today.
Well, thank you very much. Your presentation was so heartening to see what is being done in practice. And I've realized that threatening to be a brutal chairperson just does the job for me. So thank you very much for staying on time. It was superb. Really appreciate it. So now we're going to move across the sea to Finland. And I would like to ask Tommi Kapila from the Geological Survey of Finland for his presentation. Thanks very much, Tommi.
Thanks, Julie, and thanks for having me. Like Julie said, right across the globe from the very north of Europe. And I have just one point to make, and that's the one that you see there, so that we need circular design for mining projects. This was already displayed by Will before me by one example. But I'm going to use 7 slides to explain what I mean. First, about GTK and Finland. We turn the GTK, that is 140 next year. We are around 450 people strong, and we are a government research agency operating under the Ministry of Economic Affairs and Employment. Finland is a mining country by European standards. We have 39 mines in operation, and last year we had 59 companies reporting about their exploration activities, spending 94 million euros in total for exploration in Finland. This is something that all of you know, but I thought I'd just show this. So, because most of what we mine becomes waste. This is the issue. Typically, it's well over 90%. And these are numbers from Finland from 5 years ago. So from the total mining, around 2.6, 2.7% of the mining became concentrate, and around 7% of the ore turned into a concentrate. And if you look at the mine site scale, this is what it looks like. So you have the pit. From the pit, you get a tailings material from the ore. So this one is like 1.2 by 1.5 kilometers dimensions, this tailings pond, and then you have a waste rock area and a little lorry there to transport the concentrate. And this is going to increase, like Will said. We will have more mining, so we will have more mining waste. So there is a steep upwards trend in mining waste production. So what do we do with the 90+% of the material we mine? So we, for instance, take the chalcopyrite, separate the chalcopyrite and the sphalerite, and we are left with this, which is the tailings, and this has opportunities. We can maybe make cement substitute or geopolymers, or sells the coarse grained part as sand, and maybe capture CO2 to magnesium silicates or make magnesium chemicals out of it. If we only remove one more metal, the cobalt, for instance, that won't reduce the waste almost at all. But the good news is that several novel uses of minerals and mineral mixtures have been developed, for instance, these geopolymers. And the other good news is that many of these, let's say, low value or let's say industrial mineral type uses of the tailings minerals are something that won't allow long transport. And this means that it will promote local economic activity, because you need to make something of value from these minerals at the site. So this is what we are suggesting. This busy slide is basically my message here. So what we are trying to do at the moment is that, first of all, we want to put the wastes into the ore models and also into the waste rock models. Normally you don't have a waste rock model, a very good one. But anyways, the circularity information has to go already into the deposit model. And the reason for this is that in the investment phase, this is the only information you have. But we are thinking that we still need to go by the main commodities business model, because this is what drives mining. So if someone wants to set up a copper mine, they have to do so. And from that one, you get the first flow sheet. And in this first flow sheet, most of the ore, which is the tailings, becomes waste, and a large part of the waste rock becomes wastes, and they are losing money in this first business model. So we should take a good hard look on these wastes now and to see, like, what are the other opportunities? Can we find something in the construction sector, earth construction, soil improvement, pigments, CO2 capture, whatever? And can we create a circular economy ecosystem around this? And this ecosystem does not only have the mining company, it has other industries involved. And this is the trick, I think, here. Like, how do we involve the other industries in the design phase? Because they don't have a tradition to investing in mining projects when the only information you have is drill core results from a deposit. But if we are lucky, the feasibility assessment persuades some of them to invest in this project, and then we will change the flow sheet from the first main commodities flow sheet to a more circular one. And then we operate the mine accordingly, keeping all of these different fractions that we can now valorize, keeping them separate as we mine and as we transport and as we process, so that more than one company gets rich, and the waste arrow gets thinner and thinner. And even the waste, we use this same data to document it for future generations. Now, so basically, we expect the main commodities business model still to drive the exploration and mining projects. Maybe this will change in the future, but at the moment, this is the way it is. And like I said, mining wastes are an expenditure and a risk in these models. And this is why the real cost of waste management is essential. So it's important for governments to make sure that the wastes are managed properly, and the real cost of waste management is there. And then this design circularity means simply designing recovery of additional minerals beyond the main commodity minerals in the mining process. And it's likely more economically viable and technically feasible if we design it in the process in the first place. Then we need digitalization, and we need models and sensors and digital data flows to first to separate these different materials and then keep them separate in the process. So it starts from precision mining that was already shown here. We also need to learn to separate between non-sulfide minerals. We are good at separating sulfides from silicates, but now we need to separate between silicates. We also need ways to valorize only part of the tailing stream because there is so much of it. I mean, here's the product on the right, you see the bags, and here's the tailing. So there is a lot of tailings. So we should find economic and technical ways to only utilize some of it. And we need new business models and new industrial ecosystems with different industries working together on the same mine site. This will be required. But the good news is we can leverage digitalization right from the deposit. So we can even extend the digital ownership to the deposit, and we can use it also to sell things. But like I said, unfortunately, so far, there is a lack of tradition of several industries co-investing in mining projects. So, to conclude, there is clearly a push to design new mining projects like this to recover and utilize more mineral fractions than before. Everyone is actually talking about that we are going to develop a zero waste mine. But I would argue that this can only be done in collaboration between several industrial sectors that use minerals. So the mining and metals industry business model maybe won't solve this alone. And this is, I think this is important also for this South African circular initiatives to think about this and look beyond the mining and metals industry alone. So we need we will need novel business and investment models, and we need to build industrial ecosystems like the forest industry has done. But the gains are potentially big through, of course, savings in waste management, but also increased resilience against market cyclicity, and then these local benefits from mining projects to create these positive legacies that, for instance, SACMMI is looking for. And these approaches are included in the upcoming mineral strategy of Finland, due in a few months, in the strategy of GTK, and in several research projects like SINTEM, the circularity integrated mining, which is also being adopted in Chile, and we have some other projects for this as well. So yeah, that was it. That was my kind of one point I wanted to make. Thank you.
Tommy, thank you so much. And also thank you, you're spot on time. And since you first showed Linda and I that presentation, in fact, this concept of these industrial development zones and the integration has grown quite a lot, particularly in the South African context. So thank you for sparking that idea. I'd now like to ask Jaco Skuman, who's the Chief Operating Officer of DRD Gold Ergo. Jaco, thanks for making the time. And you are sharing with us where the true rubber hits the road, because this is your operating model. Thanks a lot.
Thanks, Julia. So I'm going to try and flick through these slides fairly quickly. Essentially, our business revolves around recycling old, poorly rehabilitated tailings dumps. I'll give you some pictures just now to illustrate this. We do this mainly by using grey water or recycled water back from the tailings dams or treated acid mine drainage water. We'll run through some of the numbers, how we've reduced water utilization from 22% down to less than 7% now. In terms of potable water, we use approximately, we're about 52%, getting to about 52% of net zero through the utilization of solar and battery systems. I'll just quickly take you through that. And then once we've cleaned up the old tailings dams, these sites are then released for development. And once we've treated that material and recover some gold out of the old tailings, that goes on to a world-class rehabilitated site. And there the focus has shifted from just purely vegetation and monitoring to actual biodiversity, and we'll go through one or two of those just now. So in a very simplistic format, our business model, we take the tailings. There's two sections to our business. There's the East Strand and the West Strand. Tailings are pumped from 17 different sites at any given point in time. It's hydro mined with high pressure water that then goes to two plants, the Ergo plant and the DP2 plant. We recover the gold from there, and the processed tailings goes on to two very large tailings dams. On the left-hand side, what you'll see is the little diagram with the or the photo of a tailings dam which we've just completed reclaiming, and you can see the proximity of communities to the tailings dam. So we are, and the next few slides will highlight that even better for you. But we're essentially operating in the urban areas of Johannesburg, and hence the impact that we've got on communities and the likes is quite high. For some odd reason, there we go. All right. So just again to summarize it very quickly, we mine two different sources, a sand source and a slime source. That is then collected through and pumped through a network of pipelines to the treatment plants where we recover the gold, and then from there we deposit it onto the tailings dams. That is just to give you an indication of the extent of our operations. I'm not going to go through any of the detail, but the red line indicated to you, that's approximately 160 kilometers. To get into a little bit more detail, there's the two operating entities, and you can see the grey blocks on there. That's mining rights. The orange blocks, those are all tailings dams, but we'll go into that a little bit more detail. So that's obviously an aerial photograph of the Joburg area, stretching from Roodepoort all the way through to Springs. If you draw an orange line, then you can clearly see the various tailings dams, and this is in the heart of the Joburg area, in between 18 to 20 million people. That's the pipeline infrastructure that connects all of these tailings dams, and you can see that I'm just showing you a section of our operation now, which is about 57 kilometers across. And if you apply then just major roads and railway lines, you can see the intricacy that we have to deal with on a daily basis. Just another one example for you. This is the Crown tailings dams, the three tailings dams. This is Soccer City, just to put it into perspective for you. So that's the FNB soccer stadium in comparison to the tailings. What you can see is how close the communities are to our operations and what we're doing on a daily basis. So a lot of interaction with communities and assisting them in the process. We've also got what you can see here. All the dots are the dust monitoring programs. We've got the most extensive dust monitoring program probably in the country. I don't want to go into details. I'll quickly just slot through some of the numbers later on. What you can see on the screen here now is this is a typical sand reclamation site. Just as a interesting fact, there's legislation in place that you're not allowed to construct any dwelling within a 500-meter buffer zone around a tailings dam. Clearly, this was not adhered to. And you can see that this informal settlement has encroached onto the tailings dam. And we actually had to assist the guys in moving them, cleaning it up. That's the bottom left-hand corner. And then you can see the bottom right-hand side once we've cleaned up that area, where people then start moving back into the operation. There was a video, I'm not going to show that. This is a slime hydraulic mining site, a little bit different, where we don't have people around the site, but then if you look at the bottom right-hand side corner, that's a wetland. So again, sometimes we're not only treating or dealing with the communities, but very sensitive environmental areas to be dealt with as well. If we now take a good look at over the years, in 2008, if you look at the top right-hand side, that's the tailings dam. That there to the north of the tailings dams is the N2 highway. And this is the Rissik Street off-ramp. So for those of you that know Johannesburg well, this is literally in the heart of Johannesburg. This is before we started reclaiming the tailings dump. We then obviously reclaimed it and rehabilitated the area. And there's a very specific way that and legislation for us to remove that, go through nuclear clearance. We've got to get various regulatory clearances before we can release the land. And the bottom right-hand side, you can see the light industrial park that's been set up in that area. And the left bottom corner, that just gives you again an indication of a tailings dam right in the suburban area. Another example for you, this is next to the N3 highway. This is the major N3 highway running to Durban. Here you can see the tailings dams on the left-hand side and the racetrack. Once we removed it, again, there was a whole development and light industrial development happening in that area. As I've mentioned to you, we've got our own 60 megawatt PV plant and 187 megawatt battery energy storage system. So this produces reduces our carbon footprint by about 52%. And we're busy with a phase 2, which will probably get us to about 67% carbon neutral. Next slide. This is the 2 million ton per month ergo treatment plant, where we recover the gold. And once we've treated the material, we then deposit it onto the Brakpan tailings dam. The Brakpan tailings dam, as you can see there, we do concurrent rehabilitation of the side slopes, as well as an extensive water monitoring program and water recovery program from the tailings dam. But we've gone one step further. It's not about just vegetation and containing dust and making sure that all of that is in place. We've actually gone the way of doing an in-depth evaluation of biodiversity on our tailings dams. And the way that we do that is we also get a reference site which is close to the existing Brakpan tailings dam. I'm just going to go back to this one. So we get a reference site close to this one which has not been impacted, and you use that as your baseline to compare your impact or your effectiveness of your rehabilitation against the baseline site. Once you've done that, you can then evaluate to see how far you've come and what else you need to do. I'm not going to go through this slide. These are just various metrics used to determine the effectiveness of your biodiversity on your sites in comparison to your control site. And all I want to mention on this slide specifically is the bottom right-hand one, which is exotics. Obviously, you don't want exotics. That mainly refers to invasion species and species you don't want within the tailings dam. So we're moving, you'll see the 18% on the Withok and tailings dam. That's the picture I just showed you. So the focus for us now is to remove these exotics, and then we will be very, very close to having our mining site or our deposition site close to the reference site, and have built back the biodiversity in the entire area. Just quickly, some of the numbers. There you can see the tonnages and the gold profiles. We're not going to go through one of that. I'll bore you with that. The water consumption, you can see from 2014, we've reduced that consistently over the years from 22% down to 7%. For every ton of material that we process, we need a ton of water. And only 7% of that is made up out of potable water. The 93% is recycled or grey water that we use. You can see our dust exceedances that has reduced through that monitoring program. The hectares of land that we've vegetated, that is actually significantly more at this stage. We've done, it's sitting at about 600 hectares. Land rehabilitated and cleared from the NNR. We are, after this year, because this does not contain 2024 data, we're more than 700 hectares. Oh, sorry, there it is. 770 hectares we've cleared and put back into operation. Remembering now, that's 770 hectares in a densely populated urban area. And then at the bottom, you'll see our environmental spend and our socioeconomic spend over the years. That's something which we track, and we've got a number of initiatives in the communities, and making sure that we plow back some of that benefit into our community. Thank you, Julie.
Jaco, thank you so much. The numbers are staggering, and it shows just what can actually be done with this model. So thank you for that. Really, really appreciate it. And I hope you're able to stick around and participate in the interactive sessions, because your inputs will be fantastic. So I'd like to now hand over to John Knautz from Steinert, who's looking very much at the equipment side of things. John, I don't know actually if you're here in South Africa or in Germany. Over to you.
Hi, Julie. I'm currently in Germany, so I will be back in South Africa in 2 weeks. Yeah. Good. And yeah, thank you, Julie, for the opportunity to talk about it. What we are busy with here and what we provide to the market. So yeah, just to shoot off. So I am John Knautz. So I work for Steinert. It's a German-based company born out of, actually also in the late 1800s, out of recycling. So it's mostly magnets, and has, with the recycling market transition in over the years, where we have these days much more clever system, including still the magnets, but we use a lot of the sensor bases as well. So yeah, for the mining industry, we provide pre-concentration of the sensors, and look at the spot, yeah, trying to build a greener way of mining. So let's good. So how does Steinert fit into the conventional processes, and where does our sensor-based technology, or what does it do? So how do we read it? So pre-concentration plant feed material with sensor-based ore sorting relates to the separation between particles. So in order to separate these particles and have it, well, to have it take place, heterogeneity needs to exist in the feed material, either by lithology or morphology, in which the mineralized and the unmineralized material can be distinctive. So the question that I had for the session to myself, and which I wanted to look at, is sensor-based separation technology relevant to mining? And then also the next question was that, can sensor-based sorting influence the conventional linear mining approach to our circular mining approach, which we want to go to? So, and then before answering those questions, I think we need to have a look at what is happening and what is going on around us, and what do we see in the future of mining. So therefore, it's important that we talk about the behaviors that are changing the world. It's important to talk about the technologies that are currently changing the world, and then also the policies that are taking place and changing as we go forward. So in these days, I think number one probably is our energy transition, where we see these days that 4 to 6% of our global energy consumption attributed to our mining activities, 30 to 40% of these attributed to the commissioning and the crushing, which is the processes downstream. And then also 1 to 2% of that is directly towards the commissioning part. So going towards the ESG platform of environment, 2 major factors associated with mining in the waste mining. That be basically, I think, Tommy, you referred to it well, is the overburden stripping, the stripping and the coarse fragments that is too large and has to be moved somewhere. Tailings waste, water, chemicals, and then the acid and metal-various drainage that we need to take care of. So I think there from Jaco's side, I would also be very interested to see how they do it. That's, I think, a really great way to go forward with managing these. Good. And then on the social platform, again, catastrophic dam failures that we've seen over the years, and the intensity it has on the communities through loss of life, income, and the quality of the communities. So, I shouldn't forget about our governments, the policies. So the targets where we want to go to, and emissions, equity standards, and innovations. And hopefully today, and I would like to bring forward some of the innovations that we are looking at. So that is basically to create some context. And now I want to move over to the technologies that we have. I'm not going to spend too much time on this slide, but basically on the left, we have our magnetic separating technologies. On the right is different sensor-based sorting technologies. And this basically is what you would see in the market that we provide. So there is the chute machines and belt machines, but that's the equipment. But again, I'm not going to spend so much time on them. We can always dive back in them and where do they fit into the flow sheets, and to which flow sheets, which technology is applicable. So basically in the mining industry, what we mostly use is the sensor that you see in front of you. This is basically for a bit more complex sorting tasks where we apply basically 4 sensors in a single unit, and where it's either XRT data, XRF data, or near-infrared data, and we combine that with 3D sensors. With a 3D sensor basically applies a laser sensor that does the topography of each rock that goes through the machine, and inclusive then of color and induction properties of the materials. So how does it work? So we have a vibrating feeder we feed the ore into. That ore is then basically pushed into a mono layer in this feeder and then onto a belt system, which operates at about 2.8 meters per second. That is a transport system that will eventually take it through the sensor area. After the sensor area, we have a pneumatic system that is doing the separation work. So it's with compressed air that will be fit into the valve bar, and that valve bar has with for a 1 meter sorter working width, we do 80 valves or 93 valves, depends on our valve pitches. And then it goes up to, for a 2 meter sorter, 3 meter sorter, basically just doubles up or triples up. Air system that supplies this plant, and that's just a section that would then separate the material. So the ejected material will go to the right of the splitter, and material that has not been classified as having mineralized material in will then just drop down the first section of the chute. So that's the area where we install our sensors, which could be induction, 3D, color, laser, XRT, XRF, or near-infrared sensors. Good. Then I thought to bring the application to show tangibility in this presentation. And I think a good thing to mention here is that as I think Tommy mentioned, that we need to look at the other industries, and I think I had sort of the same idea, and specifically look at application out of the mineral industry. It is operation running in KZN, KwaZulu-Natal, close to Port Shepstone. This is a mine of Umzimkhulu Mining. They are calcium carbonate producer, and so Steinert is a customer. Steinert's customer, Umzimkhulu Industrial Holdings, operate an open cast mining operation, providing a high quality of limes, well, having a high quality of limestone deposit, and then mining that and producing various products out of that. So they established in 2007. Starting, I think we onboarded with them in around about 2016, and we started helping them with their processes and implement our equipment to help them. So basically, to look at this is basically the area where they are, beautiful lush green, and I think they do good effort to do it. On the opposite side, it's another mine that the activities there. They are here on the right-hand side. So looking at that, basically, if we look at the basic flow chart they use, so they mine, they haul, they crush, they screen, and then they bring the machine to the sensor sorter, where we initially first create 2 products for them. From there to get to the final product, we actually then put it again through a sorting system to create 2 final more products. So it's not to clean up, it's just 2 additional products that they create, dependable on which area of the mine, if it's on the limestone side or on the calcite side that they mine. So what do they get out of it? So interestingly, the first product that's taken out normally attributes to the aggregate industry or the agriculture, again, depending on which area of the pit it comes from. And then the second one of then milling it down the product, and that will then go to the industrial area. And then the last 2 after, again, sorting it, that goes into either the animal feed market or to the food market. So I think the part that we are really excited about with them and is that the process that they use. So you would see that there's no flotation, there's no processes, there's no thickener processes in the process, and simply because the ore sorting takes care of all that, and you don't need to have any chemicals added. They don't have any waste, because all of the material they actually mine has to go somewhere to a product or to a market. So I think I'm very proud of them and what they achieved. They work hard to get there, and I hope they keep on pushing where they are going. So that keeps on being a good example in South Africa how we can actually handle it. So there is a picture of the operation in the middle of the sugarcane fields. So, and yeah, as I said, this is the sensor sorters applying near infrared, color, and laser to distinct between the various rock types, the dolomites, the different calcites, and dolomite, white dolomite, or dependable on which color dolomite they need to do. And then from there on, it will be fed to the milling circuit. So they have various stockpiles, as you can see, to support the various products. So this is just what they achieved. So I had a chat with Lawrence on their operation, and he was very proud to say that they believe they are the greenest carbonate producer in South Africa, and that this is strongly supported by the sensor-based technology that helps them not to have flotation in their processes. Good. Then back to the question.
Sorry,
Yes.
John. We are running over time. Could you maybe wrap up in the next minute?
Yes.
Thank you.
Go. Is sensor-based sorting relevant to mining? Yes, I believe it can be a major influencer to conventional linear and process mining and a middle processes. So I want to jump to the point what I would like to get to is to say where do we need to focus? So what we've been focusing in the last couple of months, and I would like to really hopefully next year provide again something here that we can look at the economical influence of the block models, that when we remove waste, and basically when you look at a block model of a mine and you say, let's remove the waste of that early before you process this, what benefit does it provide you in your cost models for the cost of downstream savings, and what can we push the halo or the secondary mineralization and focus on mining not just more or deeper into the resource, but actually using mineralization, which normally we wouldn't be able to get to, because with the sensor sorter, we are able to remove waste early up, reduce the cost of processing, and get the benefit to be able to be more not so strict on our block model and actually be able to mine better block models and find mineralization sitting outside it, and yeah, basically get more copper in and stop depleting the resource at the lower rate. So yeah, I think that's basically where we are. So yeah, then I'm going to stop. Thank you, Julie.
John, thank you very much, and sorry for chasing you in those last moments. But I can see so clearly how what you guys provide fits into Tommy's flow diagram and where the sensor technology can work. And I think just when you say, you know, a calcite producer, so calcite producer is actually zero waste. It's mind-blowing. And also, when I was discussing with Litka about what you guys do, he indicated that one of your sorting technologies improves coal recovery by something like 50%. So it's those kinds of numbers that are what, you know, which is driving this project. So thanks so much for sharing that detail. Really appreciate it.
It's a pleasure. Thank you. And yeah,
okay,
it's a pleasure to present.
Really appreciate it. Okay, so we are running a little bit behind time, but this is important. So Lena Sophie, if you could jump in, and you have until, let's say, 10:53. Thank you very, very much.
Thank you, Julie, and thank you for this opportunity. I would like to mention I'm sitting in Germany as well. So John, wherever you are right now, I hope you have better weather than I have. Okay, let me quickly share my screen. I will present to you today a project. So I know it will be a bit technical. So if you have any questions, please feel free to reach out anytime or write in the chat, because I know I'm going to rush a bit. I would like to introduce you to into one of our projects we will kickstart next year, which is aiming to utilize mine-affected water and contaminated groundwater, help with rehabilitation of mine land, and significantly reduce the environmental impact of sulfuric mine water drainage. And additionally, make this water usable for example, irrigation of farmland. So just as a quick introduction to who we are, the Impact Catalyst is an NGO with focus on collective impact. So our mission is to establish inclusive, collaborative, cross-sectoral, provincial platforms, initiatives, and partnerships to increase systemic socioeconomic impact through public-private partnerships. Again, if you have any questions, please feel free to reach out. We are covering more than one sector. We are busy with agricultural projects, renewable energy, just energy transition, and so much more. My colleague will present something for you right after me. So please feel free to contact us anytime. But let's dig into the project I was talking about. I would like to talk a bit about the consortium we are working within in this project. We are working together with WAMISA. WAMISA stands for Sustainable and Climate Adapted Water Management and Mining in South Africa, which is part of the funding measure Water Security in Africa. All of this is funded and under the umbrella of the Federal Ministry of Education and Research, which is located in Germany. And this consortium consists of universities, companies, and other research entities. And we're looking at concepts for hydrogeological baseline studies for groundwater resources, water balance studies for mine residue deposits, locally adapted mine water treatment technology, remediation, revegetation concepts for MRD, and socioeconomic cost modeling for water and community involvement. So WAMISA has two projects in South So next year, beginning of next year, we're going to kickstart a pilot for in situ groundwater remediation. And I'm quickly going to talk a bit about the problem statement before getting into the technology. We are confronted with groundwater contamination of sulfate, which is quite normal for open pit coal mines. So on this site, which is located in Mpumalanga, in Brooksprit, it has concentrations of potentially exceeding 7,000 milligrams per liter, which is very high, and also calcium of up to 1,000 milligrams per liter, which is also liberated into the groundwater, and just flowing into the river system, the Brooksprit river system, and this has an effect of a groundwater pH of approximately 2, which is very low. To give you an indication of what we're talking about, the community in Brooksprit is estimated of a population of 500,000 in 2019, obviously increasing. So all of these people are affected or impacted by the poor quality of this river. Okay, what is in situ remediation? In situ means on-site, but this is not only on-site, but also within the aquifer. So in the groundwater, this water is going to be treated. It works like that. You inject some environment-friendly reagents, which can be biological or chemical, and you create a permeable remediation barrier. This has the aim to trigger and accelerate nature's own biochemical remediation processes. And you have to imagine it works like a wall. So you build a wall in the aquifer, in the ground. The water comes from the right-hand side, or here, as you can see from the left-hand side, the contaminated water flows through this barrier and treats itself. And the aim is to make this water on the right-hand side here usable for example, irrigation. No equipment remains on site that could be affected by theft or sabotage. And the contaminants are meant to neutralize or immobilize in the barrier, and that purifies the water underground. This is a well-known and applied method in Europe. Myself, I worked in Germany for a company that did exactly that. And now we would like to prove this technology in South Africa. So the project outputs and aims. So just to take you a bit through what we're going to do. Of course, we have a preparation phase, and we're gonna develop a pilot design and prove this in the laboratory, because you have to prove if it's the biological path or if it's the chemical path that works best. It's very site specific. It depends on so many factors like sodium in the soil, so on. We're going to drill some boreholes, some injection boreholes. We're going to implement the pilot. That's going to take approximately a year. In parallel, we're going to do stakeholder engagement. We're going to assess a social baseline, stakeholder identification, mapping and analysis, stakeholder engagement, and community communication plan. So we're going to go into the communities. We're going to help the communities to understand what's going on and to create some jobs and a positive socioeconomic impact. Obviously, all the boreholes need some maintenance during the pilot, and the injection campaigns has to be adjusted all the time. After every injection campaign, you look at the values that comes out, and then you adjust the next injection campaign. And the aim of this is to scale this project from a pilot to a site remediation, and to build this barrier and save the quality of the river. So I brought, to give you a bit of an idea how it looked like, or how the result can look like, I brought an example. This is an example where we implemented this methodology or this technology in Namibia already. And as you can see, the 500 milligram per liter is the target level. The blue and the orange line are upstream monitoring, and the yellow and the gray line are downstream monitoring. And as you can see, we quite fast reached our target level within this 1 year. So in South Africa, a solution and a technology is proven only when proven in South Africa. So this is what we are trying to do with this technology in the beginning of next year. So the future goal is to, as I already mentioned, to utilize mine-affected water sustainably, as for example for agriculture. So we want, with this technology, we want to meet the water quality requirements for irrigation purpose, create a realistic assessment of the impact on plants, soil and environment, which is the other project we're going to look at. So we're going to take some plants, we're going to look at the water quality and see and have a deeper look at the impact on the soil and the roots, and see what kind of heavy metals the plants did take up during this irrigation process. Sustainable interaction between water treatment, the use of this water, and the inclusion of communities by educating farmers, just as an example when we talk about irrigation of agriculture. The sustainable interaction between water that's copy-pasted. The consideration of other possibilities such as agrivoltaics and additional energy generation is also part of this project, of the other project. And several pilot projects on sites like Mafubi, also in South Africa, have already shown that irrigation with mine-affected water is possible, and it is an opportunity that's worth to have a closer look. So the next step is the sustainable and economically feasible implementation on a larger scale. Thank you. I hope I could make up some time. Julia, I tried my best.
Oh, wonderful. Thank you very much, Lena. Sophie, you spot on time. And it's amazing to see those results. I mean, literally within a year, you know, you reached your target. That's superb. So thank you for that. Really appreciate it. Just looking at the agenda now, we've got your colleague Mlungisi Sindani. Mlungisi, if you'd like to take us through your presentation of Impact Catalyst, please. Thank you.
Thanks, Julie, for the opportunity, and thanks, Lena, for taking through the colleagues of who Impact Catalyst is. So I'm going to focus on a project or program that we are running within Enterprise Supply Development, which is integrated waste management solution, where we're just trying to drive, responsible reuse, repurposing of recyclable material, and this can be in local host communities, collaboratively with all stakeholders. This can be mines, majority of our partners, but also private companies, research institutions, and responsible producer organizations that are mandated to really recover some of these materials in communities. And I think what encompasses this really is to say how do we drive a circular economy whilst impacting the lives of the locals through creating jobs, through skills upliftment, and see how we bring about innovation in processing the waste that sits either at the landfill or in the communities itself. So this program, obviously, we then align it to the SDG goals that you see there. As I said, to eradicate poverty through seeing how through a circular economy we can create sustainable jobs, but also just to come up with initiatives that are sustainable, that are really aimed at creating decent work and economic growth within the local municipalities that we work with. So in terms of the waste program, we're trying to unlock a value chain in the provinces that we work in. So we are currently in the Northern Cape, Northwest, Free State, Limpopo, and Mpumalanga, and really just to see how with the waste that is there, we can unlock, the desired outcomes that you see on your far right, speaking to the environment to say, how do we drive cleaner communities, clean streets, clean roads, minimization and reduction of waste at landfill by recovering all this waste that can be repurposed, reused, and re-put into the streamline of the value chain, and the social component of it, which I think I spoke to earlier, which really, to create jobs in a sustainable way, see how we then, through waste picker integration, we bring those reclaimers, bring some form of a structure so that at least there are incentives that they are getting as they recover the waste, selling it to buyback centers, and those buyback centers to say, how do we then, make sure that they are ran efficiently and effectively as successful businesses, and also just to investigate in terms of now beneficiating, because that's where we see sustainability and value being, where we now take that waste, we process it, and we beneficiate it to create bioproducts. And moving right along, obviously, the waste sector is one that is legislated. There are policies and plans that we are aligning this program to as impact catalyst. For instance, the National Waste Management Strategy within its third pillar, which aims to drive social economic development through the recovery of waste. And I think, as I had mentioned, we do have program focus that one targets the waste reclaimers, the people who go there in the communities, in a landfill to recover this, to say, how do we support them to better, do that recovery of these recyclables, but also just to educate them so that they understand the sorting of the waste, the categorization of waste, and just the sector in its entirety. And then through our partners, who mostly are the mines, just to see how we leverage resources together with other players within the sector to then bring infrastructure. These would be the many transfer stations, but also the waste buyback centers in communities, so that we try and limit illegal dumping sites within communities. And I think overarching then would be, behavioral change. I think I had one of the speakers speaking about behavioral change, and obviously they're using waste education, advocacy, and awareness just to start that theory of change and how communities see and relate with waste. So yeah, just to break it down quickly, within the stream of waste education, awareness, and advocacy. So we look at three legs, one being public awareness programs targeting your schools and churches, taverns and restaurants and urban areas. And obviously here we do have partners, some who are in the alcohol and beverage sector, who for them, making sure that the glass is dealt with and is not becoming, a nuisance in the communities becomes key. So we partner with them to see how do we then drive this message. And at schools, we do have those programs where to see how do we then encourage learners to say, let us recycle, let us separate at source, and just drive that message. Through our partners as well, internal advocacy programs and external advocacy programs targeting the businesses themselves to say, how do we then start conscientizing the colleagues so that also when they go home, they do practice this theory. And I think here it just speaks to us working with the waste pickers. You'll see on the far right there some of the entities that we partnered with to say, how do we then make sure that they are structured and they are working in a way that is safe to reclaim this waste, whether at landfills or in communities, so that we support them to aggregate the waste, so that at least when they sell it, there is substantial value to the waste that they have reclaimed. And yeah, this one speaks to, building and upgrading of crucial infrastructure, such as mini transfer stations. So our target here is the host communities that are nearer to the mines, to say, let us set up that infrastructure so that waste is recovered, is sorted, weighed, and taken to the buyback center to be baled or to be crushed, to be further processed. But through that also with the mind to say, let us create that economic value where at least they receive a rent for the waste that they've recovered, at least the one that doesn't go to landfill, being your plastic, paper, box, cut box, glass, and the likes. And then another one is, as I said, we have picked up that really, if we are to create sustainability, we need to bring processing of this waste and beneficiation. So meaning not just ending it at reclaiming, but see how do we then, if it's glass, how do we then take it through either to be resold or to be crushed and create other products. If it's paper, how does it get turned to pulping? If it's plastic, can it then be palletized and so forth? And I think one of the most important one that really speaks to mining is the recycling of OTR tires, which is part of this program. It's more technical, but it's one of those streams that we are looking at with the partners, because mining has, said to say they've got some of them legacy stockpiles of waste tires, which really it's becoming unmanageable and becoming an environmental risk for them. So we also looking at that solution to say, how do we downsize? How do we then further process the tires using different technologies, either to create carbon black oil through gasification and so forth. So that is the processing that we're looking at. And really, where we see ourselves at with this program, it's where we are processing and beneficiating through, various paths. As you can see the pictures there. And lastly, this picture just shows the entire value chain from the mini transfer stations, buyback center, from there, pre-processing to beneficiation. And we are saying through this, we believe that we can, drive socio-economic development, but also create value to our mining partners by ensuring that we are impacting local host communities, just to reduce dependency on the mining by creating alternative economies. Yeah, thanks, Julie.
Thanks, Mlungisi. There's a lot of incredibly valuable information in that. And I was just making note of there's some really key themes coming up, even in the very different presentation. So thank you. We have 2 more presentations to come. We are a little bit behind time, absolutely no crisis. And then we are going to take a break. So can I ask Mariki from Mintech to do your presentation? Thanks very much.
Thank you, Julie, and thank you for the invitation to present today. Just quickly, I think it's important just to know who is Mintech. Oh, my slide, there it goes. We are a research council, and our mandate is really to develop technologies which we then transfer to the mining and metallurgical industry. So I thought I'll just give you that context so that you can understand where we're coming from. Our capabilities actually range across the whole mineral value chain. After the ore comes out of the ground, we can do the characterization, we can do the minerals processing, then recovery of all valuable metals or metals of interest from those ores or concentrates. We also then look at the production of value products. We can control systems, and then we also play in the mining and post-mining landscape. So I think that gives us an opportunity to look at processes holistically, so that when you start at the beginning of the value chain, you already keep in mind that we don't want to create a lot of waste at the end of the process. How can we recycle reagents, water, etc. So that's more and more as well what clients want from us, is to look at these integrated types of processes. And then just lastly, we cover a lot of metals. We can basically recover any metal on the periodic table if you ask us to. And I think what distinguishes us and what might be useful here as well is that our facilities are pilot scale. So we can really do test work at quite large scale, which can then give you the design parameters for a detailed design and commercialization. So I'm just going to give you a brief snapshot of a few of the fields or areas that we are covering. It includes our flowsheet development, recycling and recovery of metals from waste resources. I'm also going to touch briefly on the treatment of mine impacted water, and then just the mine rehabilitation side. As I've already said, we're really working hard on making our processes more water efficient by recycling water. As you know, minerals processing consumes quite a lot of water, and what we're currently looking at is, for example, in our flotation plants, if we can keep on recycling the water and also clean it in between, say you can recycle it 4 or 5 times, then clean it and use it again and again, that would actually add a lot of value to the flow sheet. And you can see the picture of our recycling plant. So we've based it currently on the flotation side, but it would obviously also be valid in the milling and all the other minerals processing unit operations. Then we do also a lot of work in the ferroalloy side, and as you know, energy is a huge issue here, and quite a lot of these smelters have closed down because of a lack of energy. So what we are currently doing with partners from Europe is looking at how can we apply, for example, renewable energy in the preheating and drying of the furnace feed materials. How can we also reduce the carbon footprint of these processes? And I think this is a global issue, and we have been piloting quite a lot of these concepts, and the results are really very promising. Then also, we've already heard earlier about control of processes. We also have a suite of instruments and software that we can use to control processes to, for example, control the energy input, also reagent consumption. You can see as well we've got sensors for cyanide control as well, which is quite important in the gold leaching industry. And one would obviously want to minimize the use of the cyanide for cost as well as environmental reasons. Then we're currently doing quite a lot of work on waste resources. A lot of the waste currently is being exported to Europe and Asia for recovery. of the valuable metals, so and for recycling. So we've recently done quite a lot of work on looking at the smelting of autocatalysts for the recovery of PGMs, and that process can be done. We've shown that. We've also done quite a lot of work that's previously also been funded by the DSI, looking at e-waste treatment. We have both hydro and pyrometallurgical processes for those. We've spoken quite a bit about critical minerals. There's currently also a lot of interest in recovering the rare earth elements in phosphogypsum dumps, and we've done extensive piloting on this. So that's also quite a promising area that one can look at, and also rare earths from, for example, fly ash dumps would also be of interest. Then I think I saw that Linda's in the meeting. We've done a study about 4 years ago on whether there's a business case for recycling of lithium-ion batteries in South Africa. At the time we said probably not, but I think after load shedding and all the new solar installations, obviously we're going to have some issues in the next 5 to 8 years with lithium-ion batteries that needs to be recycled. So currently we are looking at processes for recycling of these batteries. We're also looking at recovery of, for example, base metals and precious metals from low-grade ores and waste rock, mainly using heap leaching processes. These are not so capital intensive, and it's been implemented in Africa, South America, etc. And then also tailings treatment has always been something that Mantic has looked at, and currently we are piloting a process that we call e-GOLI, and it's a simple, safe, mercury-free method of gold extraction from gold-containing samples, and this would be quite useful for artisanal miners. Okay, and then looking at solutions for water treatment, we are currently demonstrating a semi-passive biological process for the treatment of acid mine drainage in collaboration with Tungela, TIA, the Moss Group and University of Pretoria. And we are using waste as a substrate to the plant. The intention is to produce biosulfur, which would be can be used as a fertilizer, and the water we are planning on using for irrigation, and University of Pretoria is assisting with that. And then also we have membranes for wastewater treatment that can actually, it's nano-based, and we can treat water to drinking water quality with those. And then lastly, we are also in collaboration with the Department of Minerals Resources and Energy, looking at the rehabilitation of derelict and ownerless mines. The focus is very much on asbestos sites, and you can see on the right-hand side pictures of what's been done. And over the past few years, we've also closed quite a lot of the open mine shafts in the Gauteng area. It's mainly for to try and minimize criminal activities, but also it also has an environmental purpose. So I think I've used up my 10 minutes, and it's probably a lot of random things that I've spoken about, but I thought just to give you a snapshot of some of these activities and programs that we are involved in, and we can always talk about those later in more detail if anything is of interest. Thank you, everybody.
Thanks, Mariki. You literally hit the stopwatch on the nail, and I don't see this as random at all. It's more the sheer scope of, first of all, where you work and the scope of the possibilities of the circularity agenda. So thank you for that. And then in closing, Prof. Jenny Broadhurst from UCT is going to take us through some of the work of the, as I understand it, Jenny, the Mining to Metals project. Thanks.
Yes, thank you. I see it's taking a while to load. Is it on there? Everybody see everything?
Yeah, all good. Thanks.
Thank you very much. Okay, so just a very brief introduction. Minerals to Metals is a collaborative inter- and transdisciplinary research group that is hosted within the Department of Chemical Engineering at the University of Cape Town. And for the purpose of this particular forum, I have linked 4 of our key research and development projects relating to circularity to both the SACMMI focus areas, which Julie introduced, and the 3 circular economy principles. So one of our key research areas is the valorization of mine residues and water, mine water, and that relates then to processes. Another one is the end use recycling of products such as e-waste and batteries, so that's downstream on use. In principle, I'm looking at principle 3, which is on the regeneration of natural systems. We have a research and development thrust on post-mining land use and socioeconomic development, and then foundational to the first principle, designing out waste and pollution. We do research on the distribution of elements across the minerals to metals value chains. So what I'm going to do is similar to what Mariki did and give you a quick overview of these activities. You can always contact me if you want more information. So starting with mine waste valorization, and here I refer to valorization in the broader sense. So it includes value extraction as well as reallocation or repurposing of bulk waste as feed for other industries or purposes. And we have tended to adopt here a very multi-phased, multidisciplinary approach, which is based on the iterative innovation value chain phases of the identification of alternative options, their selection, their development, as well as implementation through technology transfer. And all of this is underpinned by knowledge of the characteristics of the waste and its associated risks. So our research takes into account then both the technical and the non-technical aspects of mine waste valorization, so doing a lot of multi-criteria decision analysis, and makes use of both quantitative and qualitative research methods. And one of the waste streams for which we have systematically developed and applied this innovation value chain approach is coal processing waste. And this work is complemented by technical studies on the pre-separation techniques to recover coal and generate both a low volume sulfide enriched and bulk sulfide lean waste stream. The use of the sulfide-enriched waste streams as an ameliorant for alkaline soils or as a source of secondary byproducts such as sulfuric acid, iron sulfates, and oxide chemicals, and then the application of sulfide lean tailings as a cover or barrier for your coarser acid-generating waste, or to produce fabricated soil. Quite a lot of research we've done in that area. Other case studies that we have or carrying on working on include the investigation of opportunities and barriers for the repurposing of gold tailings material. So this is your bulk material after primary or secondary processing, as well as the repurposing of silicate-rich waste from the mineral sand sector. We produce a lot of that waste, and there is really no work that has been done on that across the world. So recognizing that the development and realization of these valorization opportunities requires knowledge of the key characteristics of the mine waste, we also do a lot of extensive research on developing a comprehensive set of waste characterization tools and protocols, and being able to adapt these to different waste types. So this includes methods for chemical, physical, and mineralogical analysis, your geochemical tests, your mass transport models, as well as protocols for assessing metal mobility and associated risk potential. And on a larger scale, we are currently developing an atlas for mine waste in South Africa. We're starting off with a case study in the Northern Cape. In terms of acid mine drainage, we also have recently completed a study with the University of Western Cape for the selected pre-removal of iron in the form of zero-valent nano-iron, which can be used for water treatment. And here we've used green reductants such as polyphenols extracted from plants, and simultaneously generating then a purer gypsum residue, which can potentially be used for plasterboard, which has a relatively high local market growth potential in comparison to other applications. So this has been mentioned a few times, and we've also picked this up, our concerns relating to the lack of commercial implementation of these the opportunities, both that we have been exploring, as well as those that many other institutes have been exploring. This has led us to conduct research on the technology transfer barriers and constraints. And we have identified quite a few of these, which I'm not going to cover here. We have published a paper on this, except to say that one of the key amongst these is profitability. So it's not just capital costs, which is significant, but the costs of transporting bulk material around from source to market is really prohibitive. And then there is also a lot of concern about the markets and the economies of scale in South Africa. So in an attempt to overcome some of these barriers in terms of coal waste, we have conceptualized and are currently exploring a more holistic approach, which firstly considers the integration of waste streams across the entire coal value chain. So it's including your spoils and discards from primary extraction and coal processing waste, and then your fly ash from coal combustion. And which secondly aims to develop niche local applications with mine rehabilitation and mitigation of long-term environmental risks and liabilities as the key driver, as opposed to trying to make a direct profit from the sale of products. So for instance, research has shown that fly ash, with its pozzolanic properties, can be used with waste from coal mining and processing, as well as using lime or lime gypsum additives to make consolidated backfill material or fabricated soils, which can be used to rehabilitate mine sites, with the pre-treatment of acid mine drainage providing additional opportunities to recover metals. Alternatively, your fly ash can be used directly as a lime replacement in the neutralization of acid mine drainage, with the resultant gypsum fly ash mixture then used for backfill or soil fabrication. So the neutralized and metal depleted effluent can be used to generate potable water, as they are doing at eMalahleni using reverse osmosis, or it can be used directly for irrigation, and Lena Sophie spoke of this morning. So then turning then to the actual post-mining land use, once you have rehabilitated it, we have teamed up with colleagues from the School of Economics and the Law Faculty at UCT to explore the development of a post-mining industrial economy through fibrous multi-product value chains as part of a Resilient Futures Community of Practice initiative. And our studies have shown that fibrous plants such as bast fibers, hemp and knaf present a unique opportunity due to their potential to create multi-product value chains such as textiles, building materials and plant oils, all from one plant, and simultaneously, we hope, absorb metals. They certainly can do that. We're still doing research on the extent to which we can use these to absorb metals from soil and simultaneously generate fibers of a suitable quality. And similar multi-product capabilities exist for bamboo, using different parts of the plant. We have started, we did start a pilot field test in the West Rand gold fields, which was unfortunately interrupted by the COVID pandemic right in the early stages, and then subsequently AngloGold Ashanti's sale of the property that we were actually running this pilot on. But by the time we eventually did get onto the property to take samples, we found that both the bamboo and the knaf that we had planted certainly thrived in very contaminated soils, even under conditions of complete neglect. And this has been confirmed in greenhouse tests, which have demonstrated that knaf can grow really well in soils that fabricated from coal mine waste. So just moving on to then recycling of end-use materials, what we call urban mining. Our hydrometallurgy unit has been researching the recycling of e-waste, including the development of a pyromet and hydromet hybrid process for metal recovery from PCBs. Work involving stakeholder engagement to identify barriers and enablers for the development of an e-waste recycling industry, and these projects have led to a big pilot and project on complete valorization process for e-waste materials, which is sponsored by the VW Foundation. And as in the case of Mintech, we have recently got into the recycling of lithium batteries. So in particular, in line with Hydromet's expertise, they are looking at ammonia leaching for the recovery of cobalt, nickel, and manganese from lithium batteries. And then another thrust, finally, that my final slide that we are looking at, as I mentioned, is the development of tools, knowledge, and data to assess and or predict the deportment of elements within ore bodies and their distribution across entire mineral to metals value chains, taking into account the different mine and mine project life cycles, right from exploration to post-closure. To date, our emphasis, and I'm not going to run through details on this busy slide, but to date, our emphasis has historically been on the prediction of environmental risk potential, right from the early stages of a mine project, but we can just as easily extend this approach and set of tools to explore value potential, which I think would be really worth doing. So, yes, I think I just would like to acknowledge that all of this work is done in collaboration with a large number of partners, research partners and sponsors, both from within the university and external to the university. And thank you for your attention. I'm going to stop sharing.
Thanks, Jenny. Thanks, Jenny. That's, I mean, I can see already where what you are doing could link into Tommy's work, could link into Steinert's work. So certainly seeing all the linkages. Thanks for that. Colleagues, I'm aware we're running about 15 minutes late, but I'm also aware that we have been sitting still for 2 hours and the thinking part is coming now. So I'm going to say, let's take a 5-minute break. Please do come back. And then we will be doing a plenary engagement, and then we'll be doing breakaway room engagements, and then feedback to end around about 12:30. So if we can all be back by 25 to 12, that would be great. Thanks. Okay, colleagues, I know that probably wasn't even enough to go get a cup of tea, but I hope that people are back. What we're now going to do is a plenary interactive session. So I am going to share my screen, and you are going to be asked to log in to Slido, and either by using the code provided at slido.com or just using the QR code. If you can just answer, and you've got multiple chances to answer, we're just going to take 5 minutes to answer. When you think about the circular economy in relation to minerals and metals, given what we've just heard, but also given your other experiences, what activities or interventions do you think about? So as people come back, if you can just log into Slido, either via the QR code or the number at slido.com, and just start capturing in the word cloud, when you think about the circular economy in relation to minerals and metals, what activities or interventions do you think about? Right, I'm going to mute myself and just let people participate. I cannot see the chat, so if you do need to ask a question, please just unmute. Ah, someone's typing. Wonderful, thank you. I really encourage everyone just to put their thoughts in. Currently, about 8% of people are participating. So let's get that number up to 30 people typing. When you think about the circular economy and minerals and metals, what activities or interventions do you think about? There's no such thing as a wrong idea. Thanks. Okay, 1 more minute, ladies and gentlemen, but it's clear to see from the word cloud, zero waste and reuse of wastes. There's another recycling, there's waste. Those are very much the big themes. What I like, though, is also that there are systems level answers here. There are very specific answers on technologies as well. There's issues of water, soil equipment, there we go. Precision mining, yeah, that links very much into the model that Tommy was talking about. Right, it looks like most inputs are stopped. Thank you very much for this. This, to let you know how this is going to be used, this will be used in part to help define the spokes of the hub and spoke model in the way we work. In other words, what are the key themes we have to look at when we're looking at circularity in mining? So thank you very, very much for that. What I'd like to do now is we are going to, whoopsie, I'm going to have to stop sharing. Sorry about that. The joys of automatic built-in Slidos. We are going to do these breakaway rooms now, and very unsophisticatedly, I am going to ask you to take a picture of this slide. And each of you, as you have been assigned automatically, there's actually only 4 rooms. Okay, so that's between 9 and 10 people per room. And you will log into Slido on that particular code that you see there. So you'll be automatically assigned. When you're entering the room, you'll see your number. And then answer the question with discussion and be robust about it. Then you will be automatically logged out. I have set the log out to 25 minutes. And then if a rapporteur can then just share the essence, obviously we will have the record. I will display each of the results from each of the rooms. It'll be room 1 through 4. And then we will spend 15 minutes debriefing. So I hope that is clear to everybody. Just by a show of thumbs, sorry, let me keep that there. Can I see by a show of thumbs if that's clear? And can I assign everybody to their rooms?
Sorry, how long? I missed that, Julie. How long do we have?
25 minutes.
Thanks.
Okay. So enjoy. And I look forward to hearing what you come up with.
Great. Thank you very much, everybody. Just by using your reactions, what were the discussions like? Thumbs up, thumbs down, hand on head. How was it? Oh, heartbeats. Thank you, Linda. Thumbs up. Okay, cool. Thank you so much. And the fact that we still have 3/4 of the people. Oh, hang on. Room 4 is closed, but it says it. Okay, no, that's fine. The fact that we have 3/4 of the people still participating is fantastic. So what I'm going to do, I am going to share my screen and we'll just go live to, if we can start with room 1. Let me present, and whoever would like to report on room 1's findings, just take 5 minutes to share, the thoughts behind.
Julie, you're muted.
Oh my goodness. So from room 1, thanks, Samaya. Who would like to take us through? We can see the results here and I'll just scroll through them, but who would like to just take 5 minutes to share the essence of the discussions, room 1? Thank you. Okay, there's no volunteers. Let's just have a quick. Okay, go for it.
Can I nominate Jaco? I think he had a good discussion there. So,
Jaco, would you like to go again?
Yeah, sorry, it was a bit of a moaning session from my side. I was essentially in the beginning unclear on what we needed to do, so I just launched into a discussion, Julie. So sorry for that. And whether that fits into the program, we'll find out soon. But I just made the comment that and highlighted the issue of acid mine drainage and water and the quality of water in our country as a whole. And made the comment that a lot of work has been done by a lot of companies, a lot of capital has been invested by various institutions, and there's a list of technologies, probably as long as my arm, that can convert acid mine drainage into world-class potable quality water. And from personal experience, the first solution was provided in 1994 for acid mine drainage in the Grootvlei or the Eastern Basin. And since then, we've been struggling to address acid mine drainage as a country. I'm not talking about individual projects like we've got 2 or 3 treatment plants and so forth, which we use internally. I'm talking about the volumes of water, of acid mine drainage, which is contaminating our water streams. And we're talking about hundreds of megaliters per day. But the problem with that was that there was regulations that prevented the companies, the mining houses. There was a collection of mining houses that looked at acid mine drainage, and it was prevented from implementing a national solution to water because of regulatory issues and maybe ideologies. And I think for the first time in our country, we've seen it was a similar case with Eskom, where Eskom controlled the grid. And as soon as a decision was made by Eskom that they can deregulate that and private companies can access the grid, all of a sudden 6 gigawatts worth of renewable energies has been constructed by private households and private companies. And all of a sudden the grid is now being supplied by 6 gigawatts of renewable energies. And I think a similar mindset needs to be in place for us to address water. And then I just made the comment, we can live without electricity, but we can't live without water.
Sure. Okay, thanks, Jaco. So from what you've said and from what I'm reading here, there's the key themes. So the question was, what don't we know about all these interventions and what's stopping us from using them, or that is stopping us from using them? And so what you've said, it's the regulatory environment, including things like tax and actual regulations. I think there was also an element of awareness. There's here this, people need to be trained and also have proper plans. So there's an awareness factor. And then there's also this issue on collaboration. I see someone still in the room typing. That's interesting. Okay. The issues of collaboration and this whole thing about an industrial ecosystem. So, I mean, there's some very clear themes there. Thanks very much for reporting on behalf of Group 1. Does anyone else in Group 1 just want to add anything, or can we move over to Group 2? I can't see hands, so please, by all means, just jump in. Okay, room 2. Oh, sorry, Katerina, go for it.
Yeah, I think I'll quickly present, but I would ask also the rest of the people.
Sorry, is this for Group 2, Katerina?
Yes, yeah.
Okay,
sorry,
hold on, let me just
jumping in.
present. Yep, no worries.
Perfect. Let me also start my thoughts. So I think one really valid comment that was made straight at the beginning is that we kind of missed the understanding of activities within an organization, but also across organizations. So it's almost not understanding where the opportunities lies in an organization. And there we also spoke about, linked to that is smaller mining companies and how tricky it is for them to almost adopt circularity, because obviously in front on investment is it's quite a lot for smaller mining companies. So their potential opportunities would also be to almost create like mining valleys, so where organizations could collaborate and share equipment, share knowledge and experiences. I did list the South African Plastic Pact as a good example, where the entire value chain around plastic packaging is kind of gathered to actually allocate and commit to specific targets and work together. But I know within mining that might be even trickier as such. Another comment was also made that because companies and research institutions are also in competition, there's a lack, obviously, around collaboration as such that might make it a little bit trickier. We've also said that we are almost missing vertical integration. So a lot of the presentations were still, I think, about waste management and rehabilitation. But it's also about how do we actually design products such as PV, wind turbines, laptops, so that they are already designed for circularity, right? Because we still need to reduce, even though we need more minerals and metals, but we still need to also somehow reduce and curb consumption to a certain extent. And there the question is really, how do we smartly create the products that we need for a green transition? Because we still need to handle those solar panels once they reach the end of life. Another comment that was made is around to know the local recycling facilities, so that we're not shipping everything overseas, but really mapping out the waste streams that can actually be recycled locally. And then legislation, I think, which was mentioned by the previous group, was mentioned in our group as well, around that there is quite a bit of legislation around circularity. However, what we are sometimes seeing is that there is a clash of legislation, and that we need to better define words such as hazardous waste or waste as such. And then one of our participants also mentioned that, and I think that can kind of be linked also to the mining valley or whatever idea we want to call it, is having kind of like a platform that should be created to enable large and small mining companies to list their common problems. It's almost like a matchmaking platform, so that they can actually work together on issues, and also that they can do R&D together. And I think this is what you and your team are obviously also busy with. We have also mentioned capacitation and skills that are required for circularity within companies, and to also understand opportunities within the value chains, or as a mining company, access to knowledge and data is quite crucial. So the collection of probably Internet of Things and artificial intelligence to really also point out the hotspots, which the Finnish colleagues were speaking a little bit more to. So I think I can leave it at that. I'm not sure if anyone of the group members wants to add anything.
Thanks, Katerina. Thanks. It's interesting you mentioned, just specifically with what this group has been discussing, one of the things that the precinct, the MMP, is busy examining is whether we can create a broader research portfolio that we're calling it the Circular and Digital Economy Research Portfolio, because the two are so heavily linked. And I do like the idea of a circularity for mining dating site. Yeah. I see Herman is here. I think you had a critical minerals dating app. So yeah, that would be super. So the real elevation of access to information is something that we know is a high priority. So thank you for sharing that. Very appreciated. Okay, let's go into room number 3. And if anybody would like to put their hands up. My goodness, I think we have a very clear theme emerging of legislative challenges. So it's going to be interesting. Let's just wait for that. Right. Anyone from room 3?
I'm happy to, if unless anyone else wants to in the group.
Go for it, Linda.
Okay. Yeah, so I think there's a lot of detail that colleagues typed in, but I think the big themes that kind of emerged in our discussion were, again, also kind of around the legal, but also the liability. So where does one's liability end if a waste stream is reprocessed, beneficiated, if it's turned into something else? And the question was asked, will SACMMI and the research that's undertaken also help to guide and inform legislation in South Africa, or is it very kind of technology focused? There was a lot of discussion and some useful links that were popped into the chat box that hopefully we can recover later, around saying that, if we really want to unlock the value that's in mining waste streams, we need to know what's there and how important sampling is across mine sites, but also the complexity of sampling. And there were some useful links given there to the work that the University of Queensland is doing in Australia, Brazil, and Chile around sampling. And then the other big theme that kind of emerged was around a lot of the research kind of stops prematurely. We don't necessarily go as far as techno-economic feasibilities, and we know that business is not going to implement circular interventions if it doesn't make good business sense. So making sure that we understand the economics and the business case for doing something. And then also a lot of what has been developed is not necessarily yet at scale. So the importance of demonstrating these interventions, and that means that, you know, there needs to be funding that's available for such demonstration. But I think the thing that I was still kind of trying to grasp in my mind as we were coming to an end is, you know, how much of these kind of obstacles are knowledge gaps, and how much of it is kind of system implementation obstacles, whether it be, you know, that we don't have the appropriate policy to drive this, or the economic incentives, or the funding, or things like that. So I think that's something we'll still need to sort out, is, you know, where are really the gaps in knowledge where our national system of innovation can help us. Thanks, Julie.
Thanks, Linda. Well, certainly just listening to the 3 bits of feedback so far, the issue of policy as a barrier for various reasons has certainly come up. So I think one of the knowledge gaps that we're going to have to answer is why, because I don't think it's very clear as to why policy is that barrier. So thanks very much for that. Okay, going into room 4, I think there was only one item captured last. Yeah. So I don't know who would like to give feedback from room 4 in terms of the greater discussions.
Hi, Julie. I'm happy to throw my hat in the ring here slightly.
Thanks,
it
Will.
was, yeah, we kind of just had a very open discussion, and lots of the points have been raised kind of in line with the other groups. I think an issue we were talking about mainly is that the circular economy and the operations and the examples we've seen are incredibly varied and flexible, which is a benefit of circularity. But it also makes it incredibly difficult to pair that with the idea of scalability. If everything is based on a specific area, a specific location, a specific operation, how do you then pair that with scalability? And that feels like a tension that we haven't overcome yet. We were speaking about regulation, and it's interesting that regulation came up in the other groups. I think the point, and particularly Herman was saying this, is actually regulation shouldn't serve as a blocker to innovation. Innovation itself will drive itself, and if there is a business opportunity, that naturally will be taken. And I think we need to be careful, or there was a discussion around this saying we need to be careful that we do not suffocate or stop innovation due to the fear of regulation, or regulation preventing that, and actually that needing to be more of an open discussion with government and all the necessary stakeholders to overcome that. But like I say, many of the other points raised before, so I think I'll close it there unless anyone else from my group wants to pull up any other ideas I may have missed.
Thanks, Will. Are there any additions from the group?
Yeah, I think from my side, it was a great discussion. I think the other participants were expand in terms of in circular mining, if the development of the state versus the value for the miners, and also look at the capability of smaller miners. Are they able to participate in this thing? So that's how it actually went. So yeah, that's the point that we covered.
Terrific. Thanks very much. Thank
Julie,
you.
Is it possible for us to make a comment?
Of course, Jaco. Yeah.
So the comment I just want to make is that it's all related, because innovation, and some of the groups and some of the comments have raised this, that funding is required. There's a funding partner required. Scalability is an issue. They only take it up to a certain level, and they don't get to financial evaluation and so forth and so forth. The reason you're not getting to that, the reason you're not getting funding, is because there's something is blocking that funding, and that block generally gets to a point where it's based on what's the authorization process to go through. Funding, I can categorically state to you, funding is not the issue. And funding is available. The problem is if you cannot commercialize this, or you cannot get to an endpoint because there's no method of implementing the solution, everything else falls flat in its face.
Yeah. Yeah.
And that's why I don't agree with the previous comment that was made that regulations should not be a blocker. I agree it shouldn't be a blocker, but it most definitely is. And we experience it on a daily basis. Just want to make that comment, please.
Thanks, Jaco. So just a couple of comments before we close out. Part of this, the reason for this webinar is that it's starting the journey of defining the research areas. And so, I mean, we can really hear that the regulatory environment is one of the, I'm not going to say it's a research project as yet or a theme, but it certainly is something that needs looking at. And also what is part of the scope of work for SACMMI is precisely what you're saying. We have to look for demonstration cases. We have to look for what are the accelerators of adoption. And so those sorts of things will hopefully help address this issue of funding. Not getting funding, I remember working when I was working independently, the clients I was working with shared a perspective that money is never the problem. It's always about priorities. And so we do need to look at how to, what are those barriers to the funding open. But as you said, demonstration, scalability is definitely one of them. So colleagues, just in closing, I would like to share where we're going now. After this webinar, we are going to be issuing a survey. It's a long one. But we would like to gather some data, and it's pretty technical. We want to understand some of the specifics about what's being done in mining at the moment. We haven't yet decided how that will be distributed, but you may or may not get copies. We will then be holding a very focused, limited workshop with experienced mining people and potentially circularity people to look at what this webinar and the survey has come up with, so that we can confirm the key themes and the direction for the research for next year. And I mean, these are multi-year programs, but obviously we want to, especially as we are the pilot for the sub-themes, we want to make sure that we have the high priority research issues identified first. We will be issuing an expression of interest for research entities, science councils, and universities based on the themes that are identified, because we do want to, as I've said a couple of times now, elevate the connection between the National System of Innovation and the industry. And then the deliverable is a strategy for circularity in minerals and metals by the end of March, including the research strategy. So that's the direction as we're going forward. And so before we sign off, I would like to say thank you so much for, sitting for, 3 hours and participating so actively. This is where the digital world really does, this is where COVID did benefit us in getting us to learn how to use digital technologies. But for me, it has been amazing. I mean, I have got 1, 2, 3, 4. Let me quickly share. So the very key topics that I picked up were systems, it's the behavior and the representation of people, and that talks to SMMEs and big companies as well. It's the different applications of technology and the different stages of the mining value chain. It's the need to change business and operating models in mining, very different views on values, on value and what is a resource. And I do want to share, there's a concept that we're already working on called resource development zones, but that will come out in the strategy. We need to look at redefining the mining value chain, and then how we get the value chain to collaborate better. So, I mean, these are all not small small tasks, but our task is to get the research going that will help identify what needs to be done to put these things in place. So from the Mandela Mining Precinct side, thank you so much. And then I'm going to ask Prof. Linda Godfrey, as the owner of this project and the manager of Circular Innovation South Africa, just to round off with a minute's reflection on today's webinar. Thanks, Linda.
Yeah, thanks very much, Julie. And let me just first of all start by saying a very big thank you to everybody that's participated in this. I think we peaked at around 44 or thereabouts during the course of the morning. And I really do appreciate the time and the energy and the effort that everyone's contributed. I'd also like to just say thank you so much to our international speakers and our local speakers for the excellent presentations and the incredibly insightful presentations that they gave during the course of this morning. I think the 5 big kind of key take-home messages for me was there is a lot of exciting circular economy activity already happening, both within the South African minerals and metals industry, as well as within our national system of innovation. To me, and maybe it's just kind of what was showcased, but it seems like a lot of it is mostly aligned with the second principle of the circular economy, which is about keeping resources in flow, so kind of waste beneficiation, waste recycling. It's very much kind of end of pipe thinking, but we are starting to see some circular economy activities emerging upstream in the design side. You know, the presentation that Tommy gave, for example, of how do we actually design a mine from the start in terms of maximizing the circular economy opportunities. And then also in terms of the regenerating natural systems, but very importantly, more than just regenerating from kind of a post-mining rehabilitation perspective. Looking at the presentations this morning and certainly knowing what is going on in many of our universities in South Africa and the work that's kind of been done through the Waste RDI roadmap, I think there is a risk within our national system of innovation around duplication of R&D in some of these areas. And that does dilute the impact, I think, of the STI investment and hence also why this particular circular minerals and metals initiative is so important in terms of the hub and spoke model. I think the presentations from Will and from Tommy that have provided an international perspective, they've provided some innovative thinking tools, frameworks that I think certainly can help us expand what we're doing in South Africa and specifically within the minerals and metals sector. So it'd be great to have a further discussion around, you know, what's emerging internationally that we can learn from and start to adopt locally. But I think overall, the webinar for me has reconfirmed that the circular economy has relevance to the minerals and metals sector. It's not new to the South African minerals and metals sector, which is encouraging. And I do believe that there are opportunities to scale and to expand the activities that we already have within the sector, which means that there is a role for STI and there is a role for our national system of innovation. So I'm incredibly excited to see how we move forward with this. Thank you, Julie.
Thanks, Linda. And just in closing, we will be sharing an edited version of the webinar, the recording. We will share the notes and we will share the presentation. So just finally, thank you so much again. Keep an eye on LinkedIn. You're all now on our database, but do keep an eye on LinkedIn and have a fabulous day further. Take care. Bye-bye.
Bye-bye. Thank you.
Thanks all. Bye-bye.
Thank you. Bye.
Thanks, everyone. Bye.